Yes,
Hmm.
yes, yeah. No, no. Sitting.
Yeah, I can hear you.
Yeah. Uh, Other people are going to come. Do you know if other people are going to come?
No idea.
In yesterday's class, people were there, or
Yeah, in yesterday's class they were there around, I guess, 18-20 were there. I'm not sure if they're confused with the time. Maybe you can send out a reminder mail because it's different time both days, right?
yeah,
I think they're joining in.
yeah. Yesterday's class, numericals were included. In problem solving session.
Yeah.
Okay, we can start. Like for like for 2 3 minutes, let's revise what we did in the last class. Like basically in last class we discussed about what is solid waste and how what are the sources of solid waste and how we manage it, and what are the various advantages of managing solid waste, like environmental health and safety benefits, and then you have economic benefits. Uh, so after that, we studied about the history of the solid waste, right from the ancient cities to the example of bubonic plague in 14th century. Then we also seen the love canal tragedy. Uh, af- After that, we studied about the 5 R's, which is reduce, reuse, recycle, uh, and refuse and repurpose. We also seen an example of a wooden heart for understanding the life cycle assessment. We So how to define, like, what are the boundaries of an LCA, how to define them, how to choose the boundary for the LCA. And we also seen the endpoint and midpoint categories or impacts, ranging from global warming potential, photochemical ozone creation, eutrophication, acidification, and endpoint indicators, which are human health, resource depletion, and ecosystem quality. We've also seen the waste management hierarchy. Then we did some questions. In today's class, we're going to first, initially, for a few minutes, we're going to revise the second week session from sir, and then we will do some numericals. Uh, Today, like, we have numericals regarding the concepts which were discussed in week 2. So, uh, related to moisture content and density calculations, and as well as the amount of waste generated from a particular area based on population and per capita demand, per capita consumption, sorry. And then we also have some numericals on TCLP, and we have further more questions, the similar concept. So yeah, numericals today we will. Let's first discuss let's summarize the uh, things which sir taught in week 2. So basically, sir started with, initially it was first discuss about the leachate in landfill. So basically, there will be a slope provided at the base of the landfill, and there will be a pump station. Basically, a well will be there where leachate from the landfill will move into the well, and from there it will be pumped for further treatment. Similarly, for removal of gas, there will be construction of small wells or pipes within the landfills, and when the gas is collected from the landfill, it will then taken for condensation to remove the moisture content, and after that, the the gas which is left after condensation can be used, can be further used for uh, energy recovery because it contains methane. So, moving forward. Uh, After that, sir discuss about the waste stabilization. So as we discussed in the previous class also, uh, phases of landfill waste stabilization basically include three stages. First, aerobic stage, when like for when we are filling the landfill, uh, that there is a particular height decided or based on the shear strength, uh, that how much waste we can pile up, and till that height is achieved, we won't cover the particular cell or the waste uh, for that particular instant. So till then, the waste is in aerobic phase. So in that phase, the aerobic degradation happens, and the end products are CO2 and water. After that, once the waste is covered with soil, uh, for that particular cell, or the anaerobic phase starts. So anaerobic phase basically contains four stages, which is hydrolysis and acetogenesis and methanogenesis. So initially hydrolysis, and in hydrolysis and acetogenesis, uh, in hydrolysis the organic matter, the organic content is hydrocarbons are broken down with the help of water into like smaller into long chain fatty acids, and uh, long chain fatty acids, and those long chain fatty acids are further in acidogenesis state. They are further uh, undergo reaction by acidogenic bacteria to form intermediate volatile fatty acids, and this also includes CO2 and some amount of hydrogen. uh, in acetogenesis stage, those intermediate volatile fatty acids are further converted into acetate, hydrogen, and CO2. But hydrogen produced in this process is is consumed by the bacteria and converted into methane. So, and again after acidogenesis phase, in methanogenesis phase, the acetate which is uh, formed in the precursor stage is converted into methane and CO2. So once the anaerobic digestion happens, there's a overall reduction in the volume because the material which was inside the landfill is converted into gas, and the moisture which was trapped in the waste has come down in the in the form of leachate. So there will be a volume reduction, and there will be one hollow space. So because of that hollow space, air will be pulled inside, and there will be volume reduction of the landfill. And because of that air, there will be again an aerobic phase, further decomposition of the waste left after anaerobic decomposition, and the end product for that is CO2. So in waste stabilization. So basically, this graph shows basically the how the pH, BOD, and volatile fatty acids vary with different phases. In preliminary aerobic phase, normally pH will reduce due to formation of acids, and in acidogenic phase, there's still formation of volatile fatty acids and acetic acid. So there will be further reduction in the pH after that stage because acetate it get consumed by the methanogen bacteria. There will be uh, increase in the pH. Uh, for BOD, initially in the primary aerobic phase, from the aerobic decomposition, like, oxygen is available. So, but but as we go to anaerobic phase, there will be no oxygen. So, at that phase, where the organic matter which is present, if we take sample from that and we perform BOD test, BOD requirement, the oxygen demand for that waste in anaerobic state will be increasing as compared to the previous state. And further, because an anaerobic decomposition, as the organic matter is getting decomposed and converted into methane, further the BOD demand will be decreasing as we further go uh, from aerobic to anaerobic and anaerobic to further aerobic phase. Similarly, in fatty acid formation is very specific to the anaerobic decomposition. So from the second step and third step will lead to formation of volatile fatty acids, and the volatile fatty acid will be converted to in acidogenic phase they will be converted to acetic acid. In acetogenic phase, also majorly acidic formation happens in acetogenic phase. So there it, there will be increase in volatile fatty acid, and from in at third stage, this is acetogenic stage, volatile fatty acid will be converted to acetic acid. So there will be reduction in volatile fatty acids. And methanogenesis phase, all acetate is converted into methane. So specific to VFA, there will be morely listed in the acidic forming phase, which is hydrolysis and acidogenesis phase. In waste waste separation in terms of gas production, like how the different concentration of various gases changes um, in different phases from anaerobic to anaerobic to again aerobic. So initially, because air is present, so nitrogen and oxygen concentration is there. But as we go towards the anaerobic phase, there will be reduction in oxygen as well as nitrogen because air is not freely available. And because of anaerobic digestion, there will be formation of CO2. In aerobic also there will be formation of CO2. So CO2 concentration will increase. Uh, and in acid forming stage, which include hydrolysis and acidogenesis, as well as acetogenesis, there will be formation of hydrogen, but the hydrogen is consumed by bacteria to convert it into methane. So this hydrogen production is in a sense uh, sort of stabilizing for the acetogenesis reaction, because if the hydrogen partial pressure increases in the acetogenic stage, then it can hinder the acetogenic bacteria. It can it can stop the activity of acetogenic bacteria if hydrogen partial pressure increases. So, and naturally there will be bacteria which consume hydrogen which is generated at this stage, so that acetogenic stage is not hindered. Otherwise, there won't be formation of acetic acid, and there will be limited food for methane forming bacteria. And then further, for methane forming bacteria, there will be, because methane forming bacteria will convert acetic acid to methane, so you will see increase in the methane generation. Here the proportion of here the proportion of methane and CO2 is around 60-40. It varies, but normally you can consider it as 60-40. It varies between around 45 to 65%. Um, um, Moving forward. After that, we will study the various mechanism for characterization of solid waste. So there are various ways, like the regulatory through regulatory standards, where basically characterization of waste of hazardous or non-hazardous waste, and which is um, further considered as listed, and further subdivisions are based on listed and characteristic waste. The second is by source or generated as um, like waste generated from residential, commercial, or industrial or agricultural area. Third is physical characteristics, for example, mass, volume, and your moisture content, porosity, solid content, particle size, hydraulic conductivity, and there was further subdivisions in moisture content, where there was wilting point, field capacity. So, mm, moving forward to further characteristics, characterization types is component composition, which contains different identifiable waste component. For example, uh, classification such as paper, glass, metal, wood, plastic. The same similar type of example was also shown by certain class, where mm, they did it as their project, and they basically did the characterization of base in similar type of manner. And the last one is on the basis of chemical composition. So we will further see the regulatory uh, classification, basically the how the listing is done. So criteria for listing, there are basically four basic criteria for listing. The first is toxic listed waste. Second is acutely hazardous waste. Third, if any waste falls into these four categories, which is ignitability, corrosivity, reactivity, and toxicity. Fourth is based on definition of hazardous waste. If certain waste doesn't fall in another category, but it is felt that that waste uh, is hazardous in some sense or by some parameter, then it can be fall in this parameter. We will see each one. Like for toxicity listing waste, a waste typically contains harmful chemicals which indicate that it could pose a threat to human health and the environment in the absence of special regulations. So in that case, that particular waste can be included to toxic listed waste. In case of acutely hazardous waste, it says that even if we are properly managing the particular waste, it can still pose a threat to human health. So, and these wastes are fatal to human and animals even in low doses. So, that those types of wastes are included in acutely hazardous waste. The third categorization of is ignitability, corrosivity. Ignitability is basically you don't need a source to ignite a fire, a particular, for example, for fuel. Like at a certain temperature, the particular substance will catch fire automatically. So in that sense, ignitability, corrosivity, uh, reactivity, and toxicity. So in this particular sense, toxicity will be more studied by the help of a procedure called TCLP. So we will further see TCLP, which is toxicity characteristic leaching procedure. So in this procedure basically helps in determining if we are putting certain waste into the landfill, then to determine whether it's going to leach toxic substance into the landfill or whether they are permissible. We normally do toxicity characteristic leaching procedure, TCLP test. So it is mainly applicable for land means municipal solid waste landfills only. So in this test, basically the hazard solid waste material is broken down into small pieces of size less than 1 centimeter, and uh, a weight of around 100 grams of material is taken, and then it is it put it into a solution of acetic acid and NaOH. Acetic acid basically is to represent the condition inside landfill because there is generation of acetic acid due to anaerobic decomposition. And so lower the because of acetic acid, because it has a lower pH of around 4.93. In presence of NaOH, because NaOH acts as a buffer to maintain this pH. So, and the volume which is taken for the TCLP test is around 2 liters, and this 100 grams of solid waste is added to this um, solution of acetic acid and NaOH, and instead for around at the speed of around 30 rpm for 18 hours, and after that uh, the it is filtered and the leachate which is taken out which analyzed from using GC, which is gas chromatography, uh, to determine if we want to check for certain chemicals like lead, cadmium. So this is here this diagram represent the maximum concentration of particular compound when we perform TCLP test to determine that these values, for example, for lead, uh, currently the value is 5. So this 5, how we got this value 5 is basically like if we see the IS code in drinking water standards, IS 10500 1991, it is the old standard. There is a revised standard of 2012, I think. According to that, the acceptable value is 0.05 milligrams per liter. So the value of 5 we got in such a way that if once the leachate penetrates from the ground to the groundwater, we assume that there is around 100 times dilution. So if we consider like the value is if we bulk calculate from 0.05 and we multiplied it into 100, we will get the value of 5 milligrams per liter. But now, during the as per the current standard, this value has changed to 0.01 milligrams per liter for drinking water standard. So if we back calculate for that, the toxicity in the value for TCLP might also change to 1 milligram per liter. So in that way, these values of these regulatory level values in milligram per liter are calculated based on the drinking water standards. So they normally assume a dilution of 100 from landfill leachate to when it enters the groundwater. They assume that it is 100 times diluted, and based on that, they will come up with a regulatory level. So these some of the formulas which were discussed in the week 2 class. We go one by one. First is like bulk density calculation. Bulk density basically you take the total mass of a material and divide it by the total volume. Here, the volume of voids as well as uh, volume of void is included, as well as volume of mass of void is also included. Although voids doesn't contain air and doesn't have much mass. Then for dry density, from the total mass, the mass of water is deducted. So we only have the mass of the solid and divided by the total volume. So we will get the dry density. Then we have solid density. Solid density basically mass of solid and volume of solid. There is the volume of void is not included in the solid density. Then we have moisture content. And moisture content basically is the mass of water divided by total mass. Similar to moisture content, there is also called water content, where in place of total mass, only mass of solid is included. There's another formula for calculation of mass of solid. This is equal to total mass minus into 1 minus moisture content. Then we have porosity. Porosity basically represents the amount of the volume of voids divided by the to- total volume of material. Total volume of material. Then we have some more formulas like average moisture content. Average moisture content basically it is synonymous to the moisture content formula, where basically you calculate the mass of water for different components of waste, and then you add those components. You will get the total mass of water, and then you divide it by the total mass of the material. And in a slightly different fashion for uh, average density. For density, basically the volume, as we change mass, volume, there might be variation in the volume. So for you have to calculate uh, the because we have two variables which influence the gravity, so mass and volume, both are varying. So for this formula is you calculate the total mass of the uh, various components of the waste, and then you divide it by total volume, and then total volume for volume for each component you have to add, and each component volume value will calculate by uh, the standard formula of mass by density. Mass by density will give us the volume for specific component, and we add the values for different component. We will get the total volume. And then moving forward, uh, we will come for the checking the biodegradability of the waste. So for checking the biodegradability of the waste, we basically have mainly we check the volatile substances. Um, so volatile substances are divided into two categories, which is biological volatile solids and residual volatile solids. So biological volatile solids are those volatile solids which is basically destroyed during the process of biodegradation. So it is basically an organic fraction which is consumed during the biodegradation, while the residual volatile solid is that organic fraction which remains after biodegradation. Basically, these are organic molecules which are much larger in size, so they are not directly accessible for microorganism as a food, so they remain intact after the biological degradation. Other than that, there will be some inorganics like glass, metal, dirt, inorganic parts of biodegradable materials. And other than inorganics, there will be water. So this, so for calculating the biodegradable fraction, this is the formula. This is basically an empirical formula, which is which is uh, basically biological volatile solid divided by the volatile solid fraction, which this is sort of logical in logical sense when you can understand why it gives biological fraction. Then there is a formula for biodegradable fraction, which is 0.83 minus 0.028 into uh, lignin content. So here, in this formula, lignin content, the value of lignin content is put as a percentage. So now we can go for few numerical questions. This is the first question. Um, for doing questions, first you read the question and you try to do it on your own. Then we will match, like you tell me the answers if for each and every part, and after that we will discuss the question. So this is the first question. Yes, Manoj Singh. Yes,
Yeah, Divyanshu, the presentation which you are just showing, is it from our week 3 material, or it is
week two
something
material.
else?
Week two.
Week 2. So
Ji.
the presentation which you have said, that is which you are showing, it is different, or it is the one which you have
No,
said
no,
on.
no. Actually, presentation, the presentation content is week two content, and
Okay.
basically I have made the presentation. uh, it is sort of give a summary of those 5 lectures of week two. So on my behalf, I have made the presentation to give a summary.
Acha, it is just for matlab just summarizing everything, the work which was done, like that.
Yeah, yeah, yeah. Which sir has taught in week two, and
Yeah, yeah, okay.
the formula and different content, how listing is done, the TCLP test.
Okay, so you share this presentation also, or this
Yeah,
is
yeah,
from
yeah.
your end only for?
Yeah. This presentation and video, both the things are shared. So you might be getting a mail from NPTL where you will be getting a YouTube link and as well as a Google Drive link. So in Google Drive link there will be all the PPTs which will be shown in this problem solving sessions, and on YouTube link there will be videos of these sessions.
Okay.
Yeah.
Uh, uh, um, what's your good name? Yeah, Devanshu.
Yes.
Devanshu, actually, I am based at Jamshedpur,
Ji.
and at present we are also doing some this biomining work of old legacy waste that is being dumped here since a long time.
Ji.
Uh, the experiments and these formulas which you are showing,
Hmm.
all are theoretical. And
Ji.
suppose we don't have any laboratories nearby to check all these parameters. And suppose if we plan to send this, we take the sample and send it to some other place. Maybe say, if I send this sample to IIT Kharagpur, so and if it takes some duration or some time period, so in that, will there be any difference in those parameter, or that won't make any much difference?
So if degradation, like aerobic degradation or anaerobic degradation, based on what stage, like if there is landfill, if we are taking out the waste from there, so there will be that time from the extraction to till the testing. So normally when we do BOD, COD, uh, we only take 6 hours, like we are only allowed to keep the sample for 6 hours, and that
Okay.
too without temperature conditions. But if you store it below 4 degrees Celsius, normally the microbial activity is very low, very low. So if the transportation of the sample uh, is the time period is very less, or the transportation we are when we are doing it is the sample is kept at very low temperature. Like normally, it is considered below 4 degrees Celsius. So there the degradation of organic matter will be very microbial activity is very low.
Okay. But in this normally landfills, the temperature normally remains high. So
Yeah,
does this the effect if you
yeah,
keep it in a low, or if you want to say that by keeping the temperature low, we can stop the activities of
yeah.
this microbial activities or
Yes,
control the
yes,
activities.
yes, yes,
Okay,
yes.
okay.
So that further degradation, the actual value, the in situ condition, the values at in situ are not doesn't change for
Oh,
that.
okay, okay, got it. Yeah.
This sir, actually this question you can also put um, in the main forum. There, sir will also be helpful. So sir has more more experience in this field. He has done a lot of work. So if this is like it's a very practical question, if you specifically ask him, he will be more uh, he will be more like more go-to person to ask this type of specific question.
Okay, okay. Actually, we have our office timing around up to some 7:30 like that.
Yeah,
So last week also I could not join this, and in our office systems also we are not allowed to use this Google platform. So I
no
today
issues.
I just
You,
tried to join through
hmm,
this my mobile. So I just wanted one more clarification.
जी,
Say I am in Jamshedpur and not far from Kharagpur. So is it sometime possible that if we have some doubts and if we are coming to Kharagpur, we can meet sir also?
um, sir, actually, I'm a TA for this. I'm not exactly a TA for this course. I have studied in Kharagpur during my M.Tech. That's why, like, I'm family. Sir, know me like because I was the student in during my M.Tech. But currently, I'm not in IIT Kharagpur. So
Okay, no,
currently,
I can meet
yeah,
sir. Sir
yeah,
is based
you,
in Kharagpur or what?
yeah, sir is based in Kharagpur. Like for
Okay,
specifically to directly get in contact with him, there will be a group specifically for doubt solving. So
okay,
there will be TAs which are already in IIT Kharagpur and they are PhD student under Professor Dubey.
okay,
So there will be a basically a direct contact uh, to Professor Dubey. So if
right.
you get hold of any one of them, you can. I think you will be able to meet. Sir.
Yeah, because actually, why I wanted to meet us, we are doing this complete waste management from door to door, from segregation to processing. We are producing compost also, biomethanation also. We are doing MRF. So whole lot of things we are doing, and even we have
Yeah.
got a clearance, environment clearance for putting up this scientific landfill site also.
Hmm.
So, and we have three sites where one we are doing the biomining, rest two we are not doing biomining because they are some 70, 80 years old dump site. And for compaction purpose, actually, we earlier they were using this slag from Tata Steel.
Hmm.
So we are not doing biomining because if we do that along with compost, the slag will also go into the field. So we
Hmm.
have done the scientific closure work only. So a
Hmm.
lot of doubts are there in with me. So that's why I was asking if we'll get a chance to meet him, then
Yeah.
maybe we
Sure.
can have a
Sure, sir.
discussion.
He will meet you. You just have to drop a mail. You just say that I'm a student and taking the NPTEL class and I have few doubts. He will surely meet you.
Right. Okay. Okay. Yeah.
Yeah.
Okay, Divanshu.
Yeah.
Thank you.
Thank you. So let's continue with the questions. This is the first question. Like uh, first, we will you take some time to solve the question. If you don't understand the question, just ask me and solve on your own and then we will discuss. So take around 5 to 10 minutes. It is because it is a calculative question. So you might need a little bit of time. You can solve this question and then we will discuss the solution. Is that okay with everyone? If, like in that pattern we do, like you take some time to solve the question, you come up with answer, and then we will discuss.
That will be good, I think. Yeah.
Yeah,
Let us do
yeah.
that.
Has anyone completed the first part?
Is it the total moisture content, na?
Determine the moisture content of the waste. Like these are different components. If we mix all of them, what will be the
21%?
yeah 21% is correct, I think. 21.05 something.
05.
Yeah.
Yeah.
So other people have completed have attempted the question.
Yeah, I also got 21.05.
So for second part,
Second part, working on it.
okay. So similar to last time, the link actually I was not able to change the link of this meeting. So still after I think after a few minutes the meeting might get disconnected. So I will again restart the meeting. So please rejoin. We will complete the questions. Team version which I'm using is only allowing me to take meeting for 1 hour. So probably maybe after a few minutes it might get disconnected. So I will restart the meeting. We'll continue doing the problems.
Okay.
Is it 599.4 for dry density?
Uh, Dye density, it's 1 minute. Let me calculate. It will be 82.01 dye density.
The third portion actually, second I couldn't do, but third portion I have done.
Yeah. What is the answer for that?
Yeah, for compost it will be around 50,000 kg, and for MRF 1.5 lakh.
Yeah, correct. Other people also, if second, if you're not able to do, attempt third, and then we will discuss.
Uh, for weight density, is it 42, like 41.96?
I think it is 41. For weight, it is 90.366.
Then I'm not doing it right.
No problem, we'll discuss it. You can attempt the third part. Okay, okay, I will discuss the solution to the question. Um, Initially, in the table for different component of waste, we are given with mass percentage, moisture content, as well as typical density. So this is basically a bulk density. So let's assume that if we take mass, if we add all these, it will be around it will be 100%, right? So let's assume it as 100 kg. So for calculating the moisture content formula, as we saw here, the average moisture content. Like basically, you have what you do is calculate the amount of water for each component, and then you divide it by the total weight. And basically, you add the weight of all the different components of waste, and in the in numerator you have basically weight of water of all the components. So when we come to this table, so what we will do, we will just calculate the dry weight. No, we can calculate dry weight like if we have moisture content 30%, then the solid weight will be 30%. Moisture content 70%, 30% will be this the solid content, and that 30% you directly multiply with the mass. So this is basically because we have taken it as 100 kgs. So if for this it will represent 15 kgs. So 15 into zero point 0.3, 0.3 you will get 4.5. So basically dry weight. You get the dry weight for food waste. Similarly, we can calculate dry weight for
Three,
each
what is point 3?
0.3 will be because we have moisture content 70%. So solid
Right.
content will be 30%, right?
Yes.
Yeah, in this
Okay. That's
formula,
okay. Yeah.
yeah, you know,
Mm-hmm.
yeah, the solid content is total into 1 minus moisture content. So you will get solid content. So directly we will calculate in the similar manner. We will calculate the dry weight for all the components. For 45 into 0.94 will give the dry weight for paper. Similarly, the other values. So we will get the total. If we add this complete thing, this complete column, we will get the total dry weight, which will be equal to 78.95 kgs. So if this is the total solid weight, we can calculate the total water weight. That will be because total mass we have assumed 100 kg. So 100 minus 78.95 will give us 21.05. This is basically the weight of water. So if now we know the weight of water for this is basically the addition of weight of water for all the components. So if we go to formula, we basically have 21.05 is this above term, and now we have to divide with the total weight, and the total weight we have assumed is 100 kg. So this is the same thing. 100 minus 78.95 will be 21.05, and divided by 100, the total weight into 100 will give converted into percent. So we are getting 21.05 as the moisture content. So this is clear. Is there any like in this in the first part?
It's clear. Yeah.
So for second part, we need to calculate the density, the wet density and dry density. So let's visit the formula first. So this is the formula for calculating the average density. So the numerator term is basically total mass, total mass of the different components of the waste, like mass of the paper plus mass of the plastic plus. So all the component mass of all the components we have to add, because upper term is always mass and the denominator term is volume. So here for calculating volume, we for every component we have to calculate volume. So if we reverse the formula for density, if we want to calculate the volume, we bring density below and volume here. So we will calculate the volume for each component, and then we will add all the components volume. So by that we will get the average density. Same thing we have done here. What we did first is we calculated the total volume. So how we calculated the total volume? We basically took the as we already assumed that this total mass is 100 kgs. So every percentage will by itself represent the mass in kgs, right? So it will be 15 kgs. So 15 kgs divided by the typical density. So mass divided by density will give the volume for food waste component. Similarly, 45 divided by 85 will give the volume for paper component. So we will get the total volume by this method. So we got the total volume, right? So once we have total volume, we already know the total mass, and mass by volume will give us the density. So we total mass is 100 kgs, and the total volume which we calculated here is 1.106 meter cube. So if we divide it, we will get the density. Yeah. So is it this is clear now, or should I explain it again?
It's
Yeah. It's
clear.
clear. Yeah.
Yeah. Similarly, we will calculate it for dry density. So, but the only thing with change in dry density is we now the mass which we will consider is this dry weight, which we calculated in the first step. So mass, the dry weight we will consider, and then we will divide it with the density. So obviously the volume will turn out to be little bit less as compared to for the wet density. So the volume is a little bit on the lower side. It will be 0.9626 meter cube. And dry weight we already know because we are calculating dry density. So we will consider dry weight and volume of the dry weight. Here this 82.09 is actually answer. This will be 0.9626. When you divide 78.95 by 0.9626, you will get 82.0. Value is actually answer. This is I made a mistake here. This is actually answer. For the third step, when we're calculating, we have to calculate the if a community produce 1 kg per person per day of waste and population is 2 lakhs, how much waste has to be treated per day at the compost plant, assuming the entire food waste and garden trimming are composted. So food waste and garden trimming comes out to be 25%. If you're taking it to be 100 kgs, let's assume 25% of the total waste. So that in daily basis, these 2 lakh people will be generating around like population into per capita per capita waste generation, which is 1 kg per capita per day. So per capita uh, uh, thing, the per capita in denominator will go with the when we multiply it with the population. So multiplication of these two will give us the amount of waste generated per day from this particular community. And then when we multiply it with 0.15 plus zero point 0.1, which represent the food waste as well as garden trimming waste, so this amount of waste generated per day will get converted into amount of food and trimming waste generated per day. So this amount of waste will directly go to compost plant. And the other part is asking for waste to be treated at MRF. So other than these two components, all the other things can go for MRF facility. So if we take one and if we deduct the 0.15 and the garden trimming waste, all the other component will directly go to the MRF facility. So either we can directly divide the 15 to 10 kg per 3 kg per day by 0.25 and multiply it by 0.75. We will get the value. Or we can conventionally we can add all the fractions of other waste other than food and garden trimming, and then do the same thing, multiply it with the population of the area and the per capita per day generation of the waste. So we will get the value of 1.5 to 10 to the power 5 kg per day. This is the amount of waste which should go to MRF facility per day. So this was the first question. There's no doubt in the first question, right? Uh, when the team got disconnected when I was explaining the C part, right? Am I audible?
The moisture content, yeah, that was done. Third.
C part was done, right?
Yeah.
Okay, we can
C
move
part
to
done.
C part was I was explaining.
Yeah.
Okay, so in the first part we were calculating how much waste is going to the compost plant. So for compost plant, if we directly go to the question, here it is explained that for composting, food waste and garden trimming waste will be considered. So if we go to table for food waste, it is around 15% and garden trimming it is 10%. So total, if we add it, it will be around 25%. So, and 25% is the amount of percentage of waste will go to composting. So, but we have to calculate how much waste is generated per day. So that we will get from the like here in data population of the area is given as well as the uh, uh, per capita generation is also given per day, which is 1 kg per person per day. So if we multiply the population with the generation rate, we will get the amount of waste generated in kgs per day, right? So we can see it here. So if we this is the population which is 2 lakhs and we multiply it with 1, so we will get around 2 lakhs kg per day is the amount of waste generated, you know, amount of waste generated per day. And if we multiply it with the fraction of waste which is going to compost plant, which is point 0.5 0.15 is for the food waste and point 0.1 is for garden trimming waste, then this multiplication will give us the value, the amount of waste which will be going to the composting plant each day. Out of this 2 lakhs kg per day, around 50,000 kgs per day will be going to compost plant, which is contributed by food waste as well as garden trim. In the second part of the C, he's asking how much waste will be going to MRF facility. So other than these two components, food waste and garden trimming waste, all the other components will be going to the MRF facility. So if we can directly do it in this way that uh, like 25% is going to compost plant and rest of the 75% will be going to the MRF facility. So directly multiplying 0.75 to this 2 lakh value to 2 lakhs kg per day, and we will get the amount of waste which will be going to MRF. Or we know 2 lakh kgs per day will be generating. So out of the 2,50,000 is going to composting. So other than that will be going to MRF. So directly we will get 1.5 lakhs kg per day. So moving to the next question. So there is no doubt in the previous question, right? Hello, 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 hello. Am I audible, guys?
Yeah, you are audible.
Yeah. We moving to the next question. Next question. This is a next question. It also has some concept of TCLP also. So this is interesting. This is a good question. So you can try for yourself. Uh, take few minutes and try to solve this. The first two parts are almost similar to the first question. Only the third and fourth part will be a little bit tricky. Other than that, this upper two parts are same.
Is the first answer 949?
First answer, average density of mix is 952. I think it will be like I have approximated the volume values. You might have taken the complete value with of the volume
Yeah,
is.
absolutely.
Yeah, that's why the value is little bit less. It's okay. Do we have answer? Do we have answer for second question? Average moisture content?
Is it 41?
41. Third question, C part.
Working on same. I'm not able to follow the significance of kg wet and kg dry.
So the values which are given in the table for cadmium is the how much amount of cadmium is present when we are taking it with respect to total weight of total waste, when the water content is also included. Like let's assume, um, if I multi this is 370 milligrams per kg of wet waste. If I multiply this amount with the total wet waste, the weight of total wet waste, then I will get the total cadmium which is present in the uh, waste 8 type, right? Similarly, same thing we can do for the waste B. So we by doing this we have the total amount of cadmium present in the A and B waste combined. And now if I divide the that quantity with the total dry weight, which we can calculate by uh, multiplying zero point 0.5 to 55 and zero point 0.7 to 45, and we divide with that total cadmium value, we will get the cadmium concentration in the mixed waste. Third part complete. C. Um, Fourth, D part.
No, I'm not sure about the third part. It's
Uh,
little tricky.
do you want time to for attempting fourth, or can we go for the solution?
Possible for the next. It's not visible. Yeah.
Yeah. The hint for the fourth part is um, like for cadmium, you like basically you need here one extra information, which is that uh, for TCLP test, the
Permissible.
permissible value is 1 milligram per liter. So considering that value, you can like work out like how much what value it is allowed.
I think for that we will need to first solve the C part.
Yeah, yeah. But that won't affect. That will only influence in decision making whether you can um, uh, dispose of the waste into landfill or not. Uh, it won't influence the final, the actual value of how much waste will get leached into. No, no problem. We can discuss. So we will start with the first part only. So in first part we have to calculate the average density. The first part we have to calculate the average density. So this average density and average moisture, first two parts are like same as that of first question. The only additional column we have is for cadmium. So we can just directly calculate the same way for both waste A and waste B. In similar like in the first question, we assume it as the 100 kg and we calculate the volume for each component. So same mass by density will give the volume for that component. So if we divide 55 divided by 1120, we will get this 0.049, and in similar way 45 divided by 800 will give us 0.056 meter cube. So basically we have the volume for both the components, and we can also determine how much uh, how much water is present. So moisture content is 50, and if we directly multiply moisture content with total mass, so uh, 55 into zero point 0.5 will give us 27.5. So 27.5 will be the water for waste A, and in the similar manner, 45 into zero point 0.3 will give us 13.5, which is the water content for amount of water, weight of water for waste B. So with this information, we can calculate the average density. So average density will be total mass divided by total volume. Total mass will be 100 kgs. Here we have assumed it as 100 kgs, and with that we have calculated volume. So if we add that volume, we will have the density for this average density for this mix of waste A and waste B. Similarly, for average moisture content, we need total amount of water, and then the total weight of water, we have to divide it with the total weight of waste. So total weight of water we have calculated here, 27.5 plus 13.5, which will be 41. 41 divided by 100 into 100 will give us the average moisture content of the mix, which is 41%. And now in next question, it is asking that what is the cadmium concentration of mixed waste in milligram per kg when you considering the waste as dry. So here in this table, weight is given in terms of wet waste, like how much milligram of cadmium is present in per kg of wet waste. So from this information we can actually calculate, like if we have assumed that this A is the combination of A and B is 100 kg, so A will be 55 kg and B will be 45 kg. So with this information we can basically calculate that how much cadmium is present in 55 kgs, because this 55 kgs is the wet waste, weight of wet waste. So if we multiply 370 with 55, we will get how much milligram of cadmium is present in waste A. And in similar way, if we multiply 120 with 45, we will get how much amount of cadmium is present in waste B. So similar, same thing is done here. So we have multiplied 55 into 370 and 45 into 120. This calculation will give us the total amount of cadmium present in the mixture of waste A and B. Now, now if we are calculating, like in question it is asked, he has specifically asked for dry, but we will calculate for both wet as well as dry. So for first calculation is for wet waste. So the upper quantity is basically the amount of cadmium present, total amount of cadmium present in the mixture of waste, and then we have divided it with the total weight. So this total weight is dry weight plus weight of water. So what we assumed initially 100 kgs. So the amount which we get from this calculation is amount of uh, cadmium present in per kg of wet, because total weight of the waste is considered. Similarly, if we want to calculate for the dry waste, for dry waste the above calculation is same, because the total amount of cadmium present in total waste will remain same. The only difference will be we have just reduced the amount of the weight of water from this. So weight of water we calculated, it was around 41% was the uh, moisture content. So for 100 kgs it will come out to be 41 kgs.
Sorry, I lost you over here. So,
Yeah,
can you just go back to the question?
yeah,
So here 370 mg is present in 55 kg of the weight.
yeah.
So by multiplying 370 with 55,
No, no, no.
what are we getting?
370. No, no, no. 370 is present in per kg of wet waste. 55 kg is the um, total
So we
waste for
okay,
yeah.
got it. So can you show me the calculation once, please?
Yeah. This is for dry waste.
Mhm. 55 is the total. It's the wet waste, no?
Yeah, 55 is the amount of wet waste. How much wet waste is present, and 370 is how much milligram of cadmium is present in per kg of wet waste. So
Right, but why are you mentioning it as dry?
no, no, we will calculate. This calculation is for the total amount of cadmium which is present in the mixed waste
Okay.
per kg of
Fine.
dry waste.
And 59 over here is?
59 over here is the weight of dry waste, because we have assumed the total waste
Got it.
as 100 kgs and water content we know as 41%. So it will be directly translated as 41 kgs of water, right? So if we subtract 41 from 100, it will give us 59, which is basically the mass weight of the solids as per this formula,
Got it.
this mass of solid. So when we divide it by 59, so the above value is basically the total amount of cadmium which is present. This is amount of cadmium which is present in waste A, and this is amount of cadmium present in waste B. If we add, we'll give the total amount of cadmium present in the mixture of waste, and then we divide. If we divide this value by weight of total waste, we will get the cadmium milligrams of cadmium per kg of wet waste. If we divide it with the dry uh, weight of dry waste, then we will get the value for amount of cadmium present in per kg of dry waste. Okay. The last part is it possible for the mixed waste to fail TCLP? So for this, the essential information we need is toxicity concentration of cadmium is 1 milligram per liter. So this information is basically available in this table. So here at I think at the fourth position we have cadmium, and for cadmium the value is 1 milligram per liter regulatory level. Right. So this value we need. So what we will do is, like, we have taken the toxicity concentration for cadmium is 1 milligram per liter. Now have to now I'm assuming that y milligram of cadmium is present in 1 kg of soil or 1 kg of mixed waste. Here I'm assuming that uh, y milligram y milligram of cadmium is present in 1 kg of mixed waste, right? So if I'm taking y, so it will be around y milligram per kg of mixed waste. So now in this calculation, I have multiplied it with zero point 0.1 kg divided by 2 liter. So where this information came from? So this information is basically comes from TCLP test. So because this value is for TCLP test, right? 1 milligram per liter. So zero point 0.1 kg represent the 100 grams of waste which we take 100 grams of waste which we take for the TCLP test, right? Uh, we go to TCLP test here. We take 100 grams of the waste for any substance which we want to perform TCLP test for. We take 100 grams of that waste, and the volume of this acetic acid and NaOH solution is 2 liters. So from that, from this information, yeah. So I'm assuming that we have y milligram of cadmium in 1 kg of total waste. Here I'm calculating a limit where if the cadmium concentration from that particular limit exceeds, then it will fail the TCLP test. So I'm calculating that value कि maximum कितना concentration हो सकता है cadmium का per kg of waste. Then we will compare that value with the answer we got from in the previous question. So this is the maximum value allowed 1 milligram per liter. Now I'm assuming that I have y milligrams of cadmium in per kg of my mixed waste. And now if I multiply this value with zero point 0.1 kg, because this is how much amount of waste I'm going to take for the TCLP analysis. So the kg and kg will cancel out. So we will get the amount of if in 1 kg we have y milligram, then how much we have in zero point 0.1 kg, right? Because we are only going to take zero point 0.1 kg for the analysis. So with this we have how much milligrams of cadmium is present in 100 grams or zero point 0.1 kg of sample, and this weight, this y into zero point 0.1, this is present in 2 liter of leachate sample, right? Because for analysis we are taking 2 liters of NaOH and acetic acid sample. So this basically this whole calculation gives us the concentration. So how much amount of cadmium will be present in that 2 liter of solution? Is this calculation understood, or should I explain it again?
Primarily, we are changing units and for the tested sample.
Which unit? This unit.
No, like we are trying to get it per kg because we already know that 1 mg per liter is the toxicity.
Yeah,
Sorry.
yeah. We are not trying to change it. We are just like we know this is the value. Like whatever TCLP test we do for particular waste, whatever leachate we get after TCLP, that in that particular leachate, the concentration of cadmium should not go beyond 1 milligram per liter. We know that. Mm,
Right.
so I'm calculating, like I'm basically back calculating for, like, if I want to satisfy this limit 1 milligram per liter, that and none of the waste should go beyond this value. So how much amount of cadmium a waste can have per kg, so that it doesn't
This value.
exceed this limit.
Got it.
Yeah. So we just assumed that value to be y milligram per kg of waste. We just assumed it as y, a variable, and then because it is in, like, y mg per kg of waste, but in leachate test we are only taking 100 grams, so we are multiplying it with 100 grams so that we can calculate how much it will be, how much milligrams it will be for 100 grams. And because this weight will be dissolved in 2 liter of leachate sample, so that's why we are dividing it with 2 liters, so that we get a concentration value, like how much milligrams per liter. So that value we will compare it directly with the toxicity concentration of cadmium, which is 1 milligram per liter. When we solve this equation, we will directly get the Y value, which is 20 milligrams of cadmium per kg of soil. Because kg,
Okay, but this is in general, like
yeah,
this.
yeah. This is not specific. This is specific. We are doing specifically to for this question. There is one variable in this, which is solubility. We don't know, like, every time the complete amount of cadmium present in the waste is completely soluble or not. Like,
Okay.
to till what proportion it is soluble. So it is not like it's not a fixed value. Maybe
Okay.
if the concentration is way higher than this, but the solubility is way less, then also it might pass the concentration in the TCLP leachate will be less than 1 milligram per liter. So solubility will be the variable which makes this value, like, variable. It is not a fixed value, just a situation which we
So now
created.
we're calculating the waste stream one and waste stream two to get the information that is this something which is permissible in our given scenario.
Uh, Sorry, I didn't understand that.
Uh, the fourth question was that for waste stream one and waste stream A and B,
Yeah,
the mixed waste, should it be, I couldn't recall, but it's more onto that, should it, can you just show me the question?
yeah. We have
This
waste
one,
stream. Yeah,
fail TCLP. So we
yeah,
yet need to find out na ki it will fail or not
yeah,
because we
yeah,
have taken.
yeah. We just calculated the value. So
Yeah.
because this value is way less than uh, the cadmium concentration of the mixture which we calculated, is
Okay.
way the value is way high.
So it will
So
fail.
it will fail. For our scenario, it will fail because we are assuming that whatever
Right.
cadmium is there, it will directly get leached out into the TCM.
Okay. And when you say kg soil, it's basically waste.
Yeah, waste. It's a mixture of waste A and B, basically. So these were the few numericals. There are further more numericals. These are few some theoretical questions also. The presence of hydrogen sulfide in waste pile indicates which type of degradation.
Anaerobic.
Yeah. Second question is the process by which producible material is digested aerobically and converted into humus is called. From which process out of these four humus is generated. Yeah. Any answer for this question? Correct answer is composting. Process by which perishable material, and any material which can decay, is digested aerobically and converted into humus is called composting. Third is, what is the end product of composting?
It's manure.
Yeah. Next question is, which of the treatment method has high treatment cost? Out of these four, which is more costly method to divert waste from landfill?
Incineration.
Yeah. Next is expand TCLP.
C.
B. Toxic characteristic. Next is, which of the following statement is true about recycling of construction and demolition waste?
It increases valuable space in a landfill.
No. D is correct.
I
It
think
increases.
someone has asked that question.
Yeah.
Someone is asking to show the third question in the chat.
Uh, Third question. Hmm, this one. Next question is, if you are an appointed as an engineer in landfill construction project, the team planned to design a double liner system for the landfill. What is the recommended depth and coefficient of permeability for compactation?
It's D.
Yeah, Steve. See if it and K is less than equal to 10 to the power minus 7 centimeter per second, which is coefficient of permeability for clay soil. And it's 2 feet for single liner and 3 feet for. This is another numerical. Like it's a small comparatively. Solution is smaller. Only the question is big. You can try to solve this question. Is this question done?
Working on same.
Yeah. Do you like understood the what is asked in the question?
Yeah.
Yeah. Mm.
40.9%.
Yeah. 40.96 is correct. So basically, the trick in this question is to understand, we have to calculate the diversion waste percentage. So the concept of diversion is the our whole aim in the subject is to divert waste from landfill. So the calculating the diversion waste percentage is basically the amount of waste which is not going into landfill. So if we read this question where it is already given that the 21 tons is going to recycling and only mixed household waste and this commercial waste is going to landfill. Other than this, recyclable, construction, demolition, and leaves and miscellaneous is diverted from the landfill. So if we add recyclable, commercial waste, uh, recyclable, construction and demolition, and leaves and miscellaneous, which will give us 21 plus 108 plus 32, which will give us 161 tons. So 161 tons of waste is diverted from landfill, and because we have to calculate the waste percentage, so we can divide 161 tons with total amount of waste. So if we have to add all the values will be around 393 tons. So if you divide 161 by 393, you will get 40.96%, which will be around 41%. So 41 percentage of waste is redirected from landfill in this particular question. This is also is a similar type of question um, as the above two numericals. Here also you have to calculate the moisture content basically. This is the question: estimate the moisture content of the waste. So the same thing here also we have to do. Um, just have to calculate the weight of water and divided by total weight. Yes, you can calculate the answer and you can finish this session.
What are we supposed to calculate in this?
We have to calculate the moisture content of the waste. for this problem. These are the different component of the waste. We have to if we mix all these, what will be the moisture content of the mixture?
It's 6.5.
Yeah, 6.5. 6.5 is 6.5 is correct. Okay, for for this session, I only have this many questions. It's also about 8. So in next class, we will follow the same pattern. We will for around 20-30 minutes. We will do a summary of the week 3, and then we will do numericals based on the content covered in the week 3. Mostly thermal, the thermal treatment will be considered. I think will be covered, and other mm, maybe um, linear programming questions might be there for the uh, route determination, optimization of the route for waste collection. So if anyone has any doubt in this numericals, can ask. Otherwise, we will end the session.
Yeah, Devanshu, actually, I missed half of the session because of a network issue. So you are
No,
saying that this PPT will be available in that
yeah,
Google, that link which is provided, huh?
yes. This PPT
Okay,
as well as the video of the whole session will be will be made available to you through NPTEL team. You might be having a login page for the NPTEL, right? So there itself
yeah,
there will
login
be,
page is there.
yeah, there itself they will share you some, I think, a Excel sheet or a link of a particular Excel sheet. There will be uh, a Google Drive link as well as a YouTube link for both the lectures, which happens on Monday as well as on Tuesday. So right from the first session till the last session, all will be shared to you, all the PPTs and as well as the video recording.
Okay.
Mm. Okay, we'll meet on probably on next week.
Okay. Thank you,
Yep,
Devanshu.
yep, yep. Thank you, sir. Thank you, everyone.